As we have seen before that the shell model, the odd nucleon which moves around the central core of A-1 nucleon determine all the properties of the entire nucleus. Some of these properties are the angular momentum or the nuclear spin or the nuclear magnetic moment. We take the example of oxygen 17. In oxygen 17, the odd nucleon in this nucleus is the 9 neutron. From the energy level diagram, we see that the 9 neutron occupies the level J 5 by 2. Therefore, the angular momentum of this 9 neutron is 5 by 2. And it is the angular momentum or the spin of the entire nucleus oxygen 17. So this is the energy level diagram, and we fill the energy level diagram according to this scheme. Therefore, for oxygen 17, it consists of 8 proton and 9 neutron. 8 proton, all the energy level scheme occupied, and in the 9 neutron, we see that there is one odd nucleon in the 5 by 2. In this nucleon, in the case is neutron. One neutron is in the level 5 by 2. Since the odd neutron is in the level 5 d5 by 2, therefore the angular momentum or the spin is 5 by 2, and the party is called minus 1 to the power L, which is called plus 1. It is even party. Since L is equal to for this state. For this state, L is equal to, therefore, for oxygen 17, the party is a positive parity. So it give another example, carbon 13. Carbon 13 consists of 6 proton and 7 neutron. 6 proton, so again, this energy level diagram is occupied and filled, and the neutron is again, there is one odd neutron in the level P1 by 2. Since the odd neutron is in the level P1 by 2, therefore, the angular momentum or the spin is half. The party is minus 1 to power L is called minus 1. Odd party, since L is called 1 for the P state. So for even nucleus, we take the example of oxygen 16. It consists of 8 proton and 8 neutron. So 8 proton, so again this energy level are occupied. For 8 neutron again, the energy level are occupied, completely filled. Therefore, for even nuclei, that is even number of proton and even number of neutron, the total spin is 0. That is J is called 0. So for the odd nucleon, we have seen that in the case of odd even nucleon and uneven nucleon, so we see the property. In the case of odd nucleus, in the case of odd nuclei, the spin of the whole nucleus is determined both by the odd proton and the odd neutron. And to predict the spin of the entire nucleus, we have to follow the rule known as the no-dibs rule. So in this case, if L1 plus L2 plus J1 plus J2 is even, then the nuclear spin is I is called J1 minus J2. So if L1 plus L2 plus J1 plus J2 is odd, then the nuclear spin is J plus J2, J1 plus J2. So we'll take the case of nitrogen 14. Nitrogen 14 consists of 7 proton and 7 neutron. Therefore, for 7 proton, so we see that one odd proton is in the level 1 p half, and in the case of neutron, again, the odd neutron is in the level 1 p half. Therefore, in this case, in the case of proton, J1 is called half and L1 is called 1. And in the case of neutron, again, J2 is called half and L2 is called half. Therefore, L1 plus L2 plus J1 plus 2, this is odd parity. This is odd. Therefore, the spin is I is called 1 by 2 plus half is called 1. So the party is minus 1 and is called, so it even parity. So thank you.